Okay, so we're going to try another example of synthetic division. So synthetic division. And again, we can use synthetic division when we have a polynomial divided by something like x plus a, or some kind of a polynomial divided by x minus a. All right, so we're going to try a fun problem here. Let's try, so we've got x to the fourth plus 3x cubed minus 5x squared, say, plus 12. All right, and we want to divide this by x plus 2. All right, so our basic form for a polynomial is always going to be this x minus a, if you want to think about it like that. Otherwise, what you can think about is we don't really care what the natural form is as long as we always take the opposite of what's on the bottom. So the first thing we're going to do is we're going to pull off our, what are those things called? Coefficients. So our coefficients are, well, for the x, it's 1. That looks weird. For the x to the fourth, it's 1. Then we've got 3x cubed minus 5x squared. And oops, we're missing a guy. It doesn't say, but we have a 0x right here, right? That's our placeholder. 0x. And then we have a 12. Okay. Then for our little catty corner thingy off to the side, we're always going to take the opposite, whatever's on the bottom. So right now I have a plus 2, so I'm going to make that a minus 2. Okay. And draw my line out. First step is always to bring this dude down, so there's my 1. All right. So negative 2 times 1 is negative 2. So I add that straight down. 3 minus 2 is 1. Negative 2 times 1 is, what's that thing called? Negative 2. Yes. Negative 5 plus negative 2 is negative 7. Negative 2 times negative 7 is 14. 0 plus 14 is 14. Negative 2 times 14 is negative 28. And then I add this down. So negative 28 plus 12 gives us what? Negative 16? Come back. Negative 16. All right. So what we do is we kind of write these coefficients out, give ourselves plenty of room. I've got a 1, a negative 7, a 14, and a negative 16. Now this one on the end, remember, is always our remainder. So since it's a remainder, we have to put it over the divisor. So our divisor is x plus 2. All right. This one's our constant term. So it's fine the way it is. And so now, besides these two, after each one of these other coefficients, we put in a little box. And then we work backwards, filling up our little boxes with powers of x, starting with x to the first, x squared, and x cubed. And we connect all these. You can put plus signs there if you want. So I've got now, for my solution, is going to be x cubed, 1x cubed, plus 1x squared, minus 7x, plus 14, minus 16 over x